Yo, John DeAngelis, thanks for the phone call, dude. Yo, I'm really happy that you had this problem with class and you decided to call a real teacher about it. I think that's really big of you. All right, great job there. So the question you asked me is a really awesome one. All right, so I got these guys set up over here, some of our favorite toys to play with down in the basement. And the question is, why when you look through a glass of water, do they wink, flip upside down? So you can see them up right in the background still, but there they are, flipped upside down through my glass of water. All right, so there's a few things you have to understand here real quick. First of all, this is all about the concept of refraction. Refraction is freaking awesome, all right? Awesome thing to study. I'm not gonna go crazy into it, but if you're curious, look it up online, what refraction is and how it works, all right? The other thing I understand is how an image actually gets to your eye. So when I see those little figures out there, what's happening is light is shining down from the lights in my room. It's bouncing off of them. And as that light bounces out, it goes all around the room. But in the line that I'm looking at, light bounces off of those toys. It comes straight towards my face. And that's where the image is, all right? So let's say you picture that little Buzz Lightyear for a minute. And I want to show you how this works for reals for a second. And we're going to take Buzz, and we're going to put him right here. And Buzz is going to represent, sorry, Buzz. All right, Buzz is going to represent just Buzz Lightyear himself, the figure. But as I move him towards me, I want you to think about the light that bounces off of Buzz has to travel to me. So now as I start to move Buzz, Buzz is no longer Buzz. Buzz is just representing the light that bounces off of him. The light bounces off of Buzz and it moves towards my eyes, I don't see Buzz yet. Until that light actually hits my eyes. When the light hits my eyes, it goes through a lens, just like a lens that's in a camera. Your eyeball has a lens in it. That lens focuses the light. It essentially refracts it. It bends it, okay? So it bends the light so that all the light from the top of Buzz's head to the bottom of Buzz's feet, it converges in and it forms that one little point. And your lens does it so that that point where all that light converges hits the back of my the back of my eyeball. And that's where the processing of your brain can say, oh, there's an image here, and it sees the image. Camera works the same way. The lens is what focuses that light to hit the point in the camera that's going to then process the image, all right? So that's what you have to understand for that part. Now, why does it flip? It flips because the cup that I'm using is curved. So if you want to try this experiment again, and you probably don't have one, but if you had a perfectly square, a perfectly flat cup, this would not work, all right? The reason why this works is because of the curvature of the cup. When the light travels from the air to the cup, it changes speed. So right now, the light that's bouncing off of, for example, that fireman right there on the left, is going directly from him to me, passing only through air. But once I put the cup in the way, now that light has to travel through the air, then through the cup, then back out of the cup and into my eyes. And when it enters the cup and it changes speed, because the curvature of the cup is there, when that light enters, it's forced to bend. And essentially what happens is everything flips because the top of that firefighter, picture the line of light leaving the firefighter's head. It enters the cup at the top, whereas the feet enter the cup at the bottom. The feet are forced to curve up because at the bottom of the cup, it's curved that way, right? The head, that light is forced to curve down because at the top of the cup, it's curved the other way. So because the cup curves in opposite ways, it brings the bottom of the image up and it brings the top of the image down. It also brings the left side of the image to the right and the right side of the image to the left. You can see they're flipped in that direction too, all right? And again, this is the law of refraction. You can look up more about that. It's really awesome. But whenever you enter that light into a curvature, it's going to force it to bend in this different way, all right? It can work on a flat surface if you're looking at an angle. And great example of this is if you ever look into water and you think you see something that you can just reach in there and grab, and you reach into water and grab it, and all of a sudden where your hand goes is not where the object was. That's because the light that you saw being reflected off of that object was bent when the light left the water, okay? But if you were to look at that perfectly straight down in the water, there'd be no bend because there's no angle that the light is leaving or entering that water at. All right, this cup curvature is a perfect almost sphere, so that angle works in a perfect way to actually flip this image because it's rounded like that. All right, Johnny, hope that helps. Hope your kids enjoy it. Enjoy your time. All right, bye, guys.